The first thing we're going to talk about is what we've talked about earlier with similar triangles. When we start talking about these ratios that we're going to look at with trigonometric ratios, we go back to the information that we have about similar triangles. When we studied similar triangles, we found that their sides had the same ratios. So as long as the triangles were similar, the ratios of the sides were the same. So we know that if they're similar, the angles are identical. So if these are similar triangles, we know these are congruent angles. They are the same angle. And when we put one side over the other, it was the same fraction because they were similar. And they give you the example here. All right, if they are similar, then they will have the same lengths. In this case, I actually don't know if these are similar. Did they give us similar ones? They've given us these triangles ABC, XYZ with a congruent side there. A congruent angle there. And so when we start looking at comparing sides to sides, we are going to start seeing something happen with the ratios. And it doesn't actually matter how big the triangle itself is. It only matters what the angles are. All right? If they have the same angles, then they're going to be similar triangles. So the first thing we're going to look at is this comparison between the side lengths. We're going to define these three terms, and then you're going to use them over and over. The sine of an angle is the comparison between the length of the opposite angle and the length of the hypotenuse. It is abbreviated just the first three letters. It is still pronounced sine. So sine. Cosine. That is the length of the adjacent angle compared to the length of the hypotenuse. It is also abbreviated with the first three letters, cosine. And then we have what's called the tangent. That is the length of the opposite angle compared to the length of the adjacent angle, and that is represented with a TAN. All right. There is a little shortcut way to remember this. So we are going to look at this, and they give it to you here, but we're going to write it out. Start with this triangle here. When we talk about comparing these, the first thing we have to know is which side we're talking about, which angle we're talking about. So for starters, we're going to talk about angle A. This is my right angle. So my hypotenuse will always stay the same. Which side is my hypotenuse here? Which side is my hypotenuse? Is it AB, BC, or AC? AC. So this is my hypotenuse. The other sides it was referencing, it said the word opposite and it said the word adjacent. That depends on which angle you're talking about. In this case, we are going to talk about angle A. All right, angle A. If I want the side that is opposite to angle A, it is going to be, if I were to start an angle A and go across the triangle. So my opposite side, if I am talking about angle A, is going to be over here. Opposite. My adjacent side is the side that is part of the angle. If you label the other two, your adjacent's the only one left that it could be. But in this case, adjacent here, if I am talking about angle A, is going to be there. Right? Adjacent side. Now, if I were talking about B, that would completely change. All right? So if I were to, C, we're not going to do B right now. If I were to talk about angle C, that would completely change. The hypotenuse would not change. Hypotenuse would stay the same. But instead of AB being the adjacent, AB would be the opposite if I were talking about angle C. Does everybody see that? So adjacent and opposite are all in reference to the angle you are talking about. I am reiterating this because this will define everything you do with ratios. You must know how to label your triangle first. All right? You must know how to label the triangle. So then let's talk about the ratios that they mean when they say sine, cosine, and tangent. All right? The acronym that they have is called Sohcahtoa. Sine. The sine of an angle is going to be the opposite side over the hypotenuse. So Sohcahtoa is how it's referenced. Cosine. is going to be the adjacent side over the hypotenuse. And then the last one, Toa, that is tangent. That is the opposite side over the adjacent. So that is a quick way to remember the ratios they're going to ask for. So when they ask for the sine of an angle, all they're asking for is the relationship between the opposite side and the hypotenuse. If they're asking for the cosine, they're just asking for the relationship or the ratio between the adjacent and the hypotenuse. Tangent, opposite, and adjacent. That's all they're asking for when they ask for those measurements. State the values of the sine, cosine, and tangent of A. All right? So the first thing we're going to do with this triangle is we are going to label it based on angle A. All right? So you're going to find angle A. Make sure you know where that is. Which of these side lengths is your hypotenuse? The 9. Which is your opposite? The 5. Which leaves this side as the adjacent. The problem is I don't know this side length. How do I figure it out? Pythagorean Theorem. We have a right triangle, okay? So if I say a squared plus b squared equals c squared, all right? So in order to figure this out, I've got to do a Pythagorean Theorem. What is 5 squared? What is 9 squared? All right, then you're going to subtract. All right, so you want to subtract the 25 over. What do I get here? No takers on this one? 56, right? It does not have a perfect root. We're not done. We have to take the square root, right? So we have to take the square root of both sides. 56 does not have a perfect root. We're not going to put it in decimal form for this. When you do ratios, you're going to just use it in simplest radical form. So you do need to do your factor tree here, all right, for those of you that love your factor trees. All right, 2, I always start with the smallest one that I know goes into it. How many times does 2 go into 56? 28 times. All right, 2 and 2 and 7. All right. Remember, if it pairs up, it can come out of the group. What groups here? Just the 2. So square root of 56 is going to have a 2 on the outside. And this both stay in. So it's going to have a 14 on the inside. So this side length here is going to be 2 square root of 14. All right. Once I have all 3 of my side lengths, I can do these trig functions. It just wants me to give the ratios. All right. So let's start up with sine. The sine of angle A is going to be the opposite side over the hypotenuse. So my sine is going to be the fraction 5/9. Easy enough. All right. Cosine. The cosine of A is going to be the adjacent over the hypotenuse. That's 2 square root of 14 over 9. The tangent of A is going to be the opposite side over the adjacent. 5 over 2 square root of 14. I do not leave it that way. Why don't I leave it that way? What do I have in my denominator? The square root. How do I get it out of the denominator? Multiply top and bottom. Yep, by the root. So I'm going to multiply top and bottom by this root. On the top, I will have 5 times the square root of 14. On the bottom, I will just have 2 times 14 because that 14 came out of the root. So you're going to simplify that one more time like this. That is my tangent. That is my cosine. That is my sine. So they've given us an acute angle A, and the cosine is 3 over 5. They did not give us a triangle. They just gave us the information. So if they don't give you a triangle, you can draw one. All right. We are going to just draw a triangle. We're just going to label it A, B, C. That's fine. They're talking about angle A. So based on this angle, before I do anything else, based on this particular triangle that I drew, I'm going to label it. All right? I'm going to label it. They did not give me a triangle, but I'm going to label this triangle because I'm going to draw it based on this. This triangle would have an hypotenuse here. My opposite side would be BC, based on where I drew my A, and my adjacent side would be here. Okay? As long as you draw it in reference to A, it doesn't matter how you draw it. We're going to use our Sohcahtoa here. Which one did they give us? Sine, cosine, or tangent? Cosine. They gave us this one. They said the cosine of A is 3 over 5. So what is 3 based on Sohcahtoa? Which side is that? Opposite, adjacent, hypotenuse? Adjacent. Which one is 5? Hypotenuse. So I know 2 of these sides, don't I? I know that this side is 3 and that this side is 5. They want me to give the other 2 trig functions. I need to use Pythagorean Theorem to do it. This is actually a special Pythagorean triple, so this is going to be one that you probably will see over and over. But 3 squared plus the one I don't know squared equals 5 squared. B squared equals 16, so what is B? So this side is 4. Now I can do my other trig functions. They want the sine of A. That's going to be opposite over hypotenuse. What is my sine going to be? 4/5, right? They want the tangent of A, which is opposite over adjacent. What is that going to be? 4/3. You do not change it to a mixed number. Leave it as an improper fraction. So this would be my answer here. All right, we're going to quickly talk about special right triangles because we're going to use some calculator to see these trig functions. All right, they show you a special right triangle. If you remember them, remember on a 45, 45, 90, your side lengths are exactly the same and your hypotenuse is the side length times the square root of 2. So if we were to take this and use the trig for a 45, my opposite would be x, which is what they have here. My hypotenuse would be x square root of 2. My x's will reduce, and I get 1 over the square root of 2. And I multiply top and bottom, I get square root of 2 over the square root of 2. So in your calculator, if you were to do the sine of a 45-degree angle, you will get this decimal. If you were to take the square root of 2 divided by 2, you will get this decimal, all right? A couple things when you're using your calculators. We're going to do everything in degrees. So you need to check your mode. One of the ways to do it right now is to check the sine of a 45-degree angle. So if you have your calculator, check and see if you have sine of a 45-degree angle equal to 0.7071. What I want to point out is that your calculator is always going to give you a decimal when you use sine and cosine, all right? The fact is, all it's doing is it's giving you the ratio in decimal form. All right, it's giving you the ratio in decimal form. That's what it's doing. This is going to be a non-repeating, non-terminating decimal. So they have rounded it because square root of 2 is a non-repeating, non-terminating decimal. All right, but they have rounded it to this decimal place. But when you get a decimal for sine or cosine, all they're doing is giving you the ratio between the opposite and the hypotenuse, or the adjacent and the hypotenuse. They're just giving it to you in decimal form. If you'll recall the other special right triangle, the 30, 60, 90, you're also going to get the same ratio. So, for example, they are giving us the sine of a 30-degree angle. When you set up the sine of a 30-degree angle, you get x over 2x, which is 1/2. So again, in your calculators, if you do sine of 30, you should get 0.5. Sine of 30 should always give you 0.5 if you are in degrees. All right? And so all they're showing you when you put it into your calculator is that it's just giving you these ratios, these fractions, in decimal form. All right, but it is still giving you the length of one side compared to the length of the other side in that triangle. All right, so find these two. Sine of 30 we already did. Find the tangent of 22.75 in your calculator. Tangent of 22.75 in your calculator. And round to 4 decimal places. 4 decimal places for these. Painter leans his extension ladder against the wall of a house as illustrated. State the decimal approximations of the sine, cosine, and tangent of the angle formed by the ladder in the level ground. Which of these expresses the slope of the ladder? Which of these expresses the slope of the ladder? All right, so the first thing we're going to talk about is the sine, cosine, and tangent. They have given us this triangle here, and they have given us the base of 6 and the height of 20, all right? The first thing we need to do is we need to figure out the hypotenuse here, all right? Since we're doing it in decimal form, we actually don't have to simplify this hypotenuse. We just need to know what it is. So we're going to use Pythagorean Theorem to do this. So we're going to say 6 squared plus 20 squared should equal my hypotenuse squared. So we're going to have 36 plus 400. My hypotenuse is the square root of 436. So if they're wanting it in decimal form, you don't have to simplify it. If they want exact, then you need to simplify it. So know the difference between a decimal approximation. That means put it in your calculator. If it says the word exact, it wants you to leave it as a radical, okay? So they want the sine, the cosine, and the tangent of the angle formed by the ladder and level to the ground, all right? So when they want the one from the ladder and level to the ground, they want this angle right here, all right? So we're going to talk about this one right here, which means we are going to label everything based on this. The square root of 436 is my hypotenuse. Which side is my opposite, the 6 or the 20? The 20 is my opposite, which means the 6 is my adjacent. And so now I can do these 3. So the sine of this angle that is formed is going to be 20 divided by the square root of 436. What do you get when you do that? 2 decimal places. You should get approximately 0.95 or 0.96 for 2 decimal places. We'll just do 2. Cosine then, 6 over the square root of 436. What do you get when you do that? 2 decimal places. And then tangent is actually going to be opposite over adjacent. You can actually reduce this one, right? But it's a repeating decimal here. Tangent's the only one that should ever give you something bigger than 1. All right, so in your calculators, if you get an answer bigger than 1 for sine or cosine, you've done something wrong. It actually should error out on you. So my hypotenuse is my denominator for both my sine and my cosine, and it is the longest side. If my longest side is my denominator, I should never be bigger than 1. All right, the only time my number should be bigger than 1 is if my numerator is larger, okay? The only time that can ever happen, the only time your numerator can be larger than your denominator in these 3 trig functions is for tangents. These 2 should always be less than 1. 1 or less.